All right, as I mentioned, I'm going to finish up these last few questions so you can use them as practice. So ideally work these on your own and then come back and check your answers. And then you can obviously watch through the video if you still don't understand, okay? So this one, it's giving you a certain mass of this solute, chlorobenzene, and it's asking for volume. We can assume this is in milliliters just because that's easier. They don't specify either. And then they're telling you a concentration of 15 parts per billion. So just like the one above, because they're starting you with a number with a single unit and ending with a single unit, you know that you're going to be using this as a conversion factor, not starting with it. When we do parts per billion, we would write that as 15 grams of solute per a billion, so 10 to the 9th grams of solution. Okay, and we're starting with 5.00 times 10 to the second, or 500 milligrams of solute. And we're trying to get to volume of the solution. Now, I'll tell you, technically this says volume of water, which would be the solvent. But because this is so small of a concentration, the volume of the solution is going to be, for all intents and purposes, equal to the volume of the solvent, water. Okay, so I probably should just reword this question because I wasn't intending for you to go through and, you know, change this to solvent, but just if you did do that, you'll get the same answer. Okay. All right, so we're going to go ahead and first convert this to grams, and this is still of solute, and then we're going to use this conversion factor, the 15 parts per billion, but I'm going to flip it around so that the grams of solute cancel and get me into grams of solution. And then all I have to use is the density to get me to mils. Okay, so solving that one out. Oh, of course, it doesn't put it in. Okay, 3.33 times 10 to the 1, 2, 3, 4, 5, 6, 7. It looks to the 7th. My calculator didn't do it for me, and my eyesight is terrible. Yep, there we go. I verified 10 to the 7th. Okay. So similar to the one above where we're starting with a certain amount and using it as a conversion factor. Oh, this one should be really straightforward because it's just molarity, but good reminder anyways. So 50 milliliters, and they want to know how you make a 0.08 molar solution. What they mean is how many grams of potassium chromate are you going to have to add to your 50 ml volumetric flask, and then fill it up with water. So when it asks a question like that, it's asking about grams because it wants to know how you're going to prepare it like in a laboratory setting. So we're going to go ahead and use the molarity again as a conversion factor to get us to grams. Okay, so we just need molar mass there. Which is 194.189 0.96. So this comes out to be 0.77, just two significant figures, so 0.78 grams of potassium chromate. And as far as a description, you would say you add 0.78 grams of potassium chromate to the volumetric flask, add some water, mix it up, then finish it off so that the total volume is 50 milliliters. Okay, this one is a dilution problem. So there's a 0.459 molar solution that has a volume of 252 milliliters. And they want to know what the new molarity is after 45 milliliters has evaporated. Okay, so you know it's a dilution equation because you've got two volumes and one molarity, and they're asking you for a new molarity. So the new volume is going to be 252 minus 45, or 207 milliliters. So the new molarity, this is actually getting more concentrated because you're evaporating, will be 0.559 molar.